SQLAlchemy, Cascade delete. I must be missing something trivial with SQLAlchemy's Cascade options because I cannot get a simple Cascade delete to operate correctly. If a parent element is deleted, the children persist, with null foreign keys. I've put a concise test case here. Output. There is a simple, one-to-many relationship between parent and child. The script creates a parent, adds 3 children, then commits. Next, it deletes the parent, but the children persist. Why? How do I make the children cascade delete?
The problem is that SQLAlchemy considers child as the parent, because that is where you defined your relationship. It doesn't care that you called it child, of course. If you define the relationship on the parent class instead, it will work. Note child as a string. This is allowed when using the declarative style, so that you are able to refer to a class that is not yet defined. You might want to add delete orphan as well. Delete causes children to be deleted when the parent gets deleted. Delete orphan also deletes any children that were removed from the parent, even if the parent is not deleted. Edit, just found out. If you really want to define the relationship on the child class, you can do so, but you will have to define the cascade on the backref, by creating the backref explicitly, like this. Implying from SQLAlchemy.orm import backref.
Pretty old post, but I just spent an hour or two on this, so I wanted to share my finding, especially since some of the other comments listed aren't quite right. TL, drive. Give the child table a foreign or modify the existing one, adding on delete equals cascade. And one of the following relationships. A. This on the parent table. B. Or this on the child table. Details. First off, despite what the accepted answer says, the parent/child relationship is not established by using relationship, it's established by using foreign key. You can put the relationship on either the parent or child tables and it will work fine. Although, apparently on the child tables, you have to use the backref function in addition to the keyword argument. Option 1, preferred. Second, SQLAlchemy supports 2 different kinds of cascading. The first, and the one I recommend, is built into your database and usually takes the form of a constraint on the foreign key declaration. In PostgreSQL it looks like this. This means that when you delete a record from parent_table, then all the corresponding rows in child_table will be deleted for you by the database. It's fast and reliable and probably your best bet. You set this up in SQLAlchemy through foreign key like this, part of the child table definition. The onDelete equals cascade is the part that creates the onDelete cascade on the table. Gotcha. There's an important caveat here. Notice how I have a relationship specified with passive_deletes equals true. If you don't have that, the entire thing will not work. This is because by default when you delete a parent record SQLAlchemy does something really weird. It sets the foreign keys of all child rows to null. So if you delete a row from parent_table where it equals 5, then it will basically execute. Why you would want this I have no idea. I'd be surprised if many database engines even allowed you to set a valid foreign key to null, creating an orphan. Seems like a bad idea, but maybe there's a use case. Anyway, If you let SQLAlchemy do this, you will prevent the database from being able to clean up the children using the on-delete cascade that you set up. This is because it relies on those foreign keys to know which child rows to delete. Once SQLAlchemy has set them all to null, the database can't delete them. Setting the passive _deletes equals true prevents SQLAlchemy from nulling out the foreign keys. You can read more about passive deletes in the SQLAlchemy docs. Option 2. The other way you can do it is to let SQLAlchemy do it for you. This is set up using the cascade argument of the relationship. If you have the relationship defined on the parent table, it looks like this. If the relationship is on the child, you do it like this. Again, this is the child, so you have to call a method called backref and putting the cascade data in there. With this in place, when you delete a parent row, SQLAlchemy will actually run delete statements for you to clean up the child rows. This will likely not be as efficient as letting this database handle it for you, so I don't recommend it. Here are the SQLAlchemy docs on the cascading features it supports.
At Stevens an hour is good when you are deleting through session.delete, which never happens in my case. I notice that most of the time I delete through session.query.filter.delete, which doesn't put elements in the memory and deletes directly from DB. Using this method SQLAlchemy's cascade =all, delete doesn't work. There is a solution though, on delete cascade through DB. Note, not all databases support it.
Alex Okrushko answer almost worked best for me. Used on-delete equals cascade and passive _deletes equals true combined. But I had to do something extra to make it work for SQLite. Make sure to add this code to ensure it works for SQLite. Stolen from here, SQLAlchemy expression language and SQLite's on delete cascade. Stephen is correct in that you need to explicitly create the backref. This results in the cascade being applied on the parent, as opposed to it being applied to the child like in the test scenario. However, defining the relationship on the child does not make SQLAlchemy consider child the parent. It doesn't matter whether relationship is defined, child or parent, it's the foreign key that links the two tables that determines which is the parent and which is the child. It makes sense to stick to one convention though, and based on Stephen's response, I'm defining all my child relationships on the parent.